today's next point is magnetic dipole moments. So what is the magnetic dipole moment? We know that the electric dipole moment P is equal to Q into toy cell, right? This is the electric dipole moment. And now here we study the magnetic dipole moment. We know that in magnetic field, torque is responsible for the rotation of a current carrying coil. That means the torque is exerts on the current carrying coil which is kept in a magnetic field, and that magnetic torque is tau is equal to NIAB sin theta, right? We have already seen that the torque acting on a current carrying loop or the current carrying wire is NIAB sin theta. Here we study the magnetic dipole moment. Here we define the constant mu is equal to NIA. Here mu is equal to NIA. What is NIA? Here N is the number of turns to the current carrying wire, and I is the current passing through that wire, and here A is the area of that current carrying coil or the loop. Here the term mu is called as the magnetic dipole moment. Now what is the direction of that magnetic dipole moment? The direction of that magnetic dipole moment is perpendicular to the plane formed by that current carrying loop or the wire, that right. Also, how to define magnetic dipole moment? Here magnetic dipole moment is NIA for the current carrying coil. Now next point. Now here we solve this MCQ. An alpha particle of positive charge plus twice E is compelled to rotate along a circular path of radius r in a cyclotron with linear speed v. Now the magnetic moment of the closed loop is how much? Here the charge on a alpha particle is given, that means q is equal to what? Q is equal to plus twice e. Now here linear velocity is how much? V, and radius of that loop is r. Now the MCQ options are in E, V and R. So here we find out the relation in between magnetic moment, E, V and R. Okay, यांच्यामध्ये असलेलं आपल्याला relation find करायचं. We know that the magnetic moment is how much? Magnetic moment for the loop is how much? Current I into A. Suppose this loop has n number of turns, then the magnetic moment is NIA. Here we consider the single loop. Therefore the magnetic moment is I into A. Here आता बघा इथे ऑप्शन मध्ये कुठेही I दिलेला नाहीये किंवा A दिलेला नाहीये, म्हणजे I चा आणि A चा फॉर्म्युला या गिवन नुसार आपल्याला परत एकदा जनरेट करावा लागेल. मग I कसा डिसाइड करतो आपण? यू नो दॅट करंट I इज नथिंग बट इट इज द रेट ऑफ फ्लो ऑफ इलेक्ट्रिकल चार्ज. ठीक आहे, मग दॅट मीन्स हियर वी कन्सिडर I इज इक्वल टू व्हॉट? Q upon T. This is the rate of flow of charge. And what is the area of the loop? Area of the loop is pi r square. ठीक आहे, this is the area of the loop pi r square. आता बघा इकडे चार्ज किती गिवन आहे आपल्याला? twice e गिवन आहे. Here we get twice e divided by t pi r square as it is. ठीक आहे, तर याला अशा पद्धतीने रिअरेंज करायचं का जो आपला ऑप्शन असू शकतो. मग हियर वी गेट e in bracket 2 pi r divided by t as it is and into the another r. ठीक है, now what is the bracket here? Bracket 2 pi r, this is the circumference of circular loop or the closed loop. That means here this is the distance divided by time, that means this is the velocity. But here we get the answer EVR, right? But this is the option C. Correct answer of this MCQ is C, EVR. ठीक आहे, सोपा फॉर्म्युला आहे मॅग्नेटिक मोमेंटचा, फक्त तो ऑप्शन कसे दिले त्यानुसार आपल्याला फक्त रिअरेंज करावा लागला. नाउ नेक्स्ट पॉइंट इज द मॅग्नेटिक पोटेंशियल एनर्जी ऑफ ए डायपोल. नाउ व्हाट इज वी केप्ट द मॅग्नेटिक डायपोल in a magnetic field. So what happened? This magnetic dipole moment possess the potential energy because of its orientation, right? When the magnetic dipole is freely suspended in a magnetic field, what happened? This magnetic dipole moment possess the magnetic potential energy and this magnetic potential energy is due to what? Its orientation in magnetic field. Here we know that the electric potential energy of the electric dipole is what? u is equal to minus p dot e, that means its value is pe cos theta. What is theta here? Theta is the angle between the direction of a electric dipole and direction of a electric field intensity. Now similarly, here we compare the electric field and magnetic field, that means by using the analogy in between the electric and magnetic field, so what is the magnetic potential energy for the magnetic dipole? Here the magnetic potential energy for the magnetic dipole is minus mu vector dot b vector. Here its value becomes minus mu b cos theta. What is mu here? Mu is the magnetic dipole moment, and you know that for the current carrying coil this magnetic dipole moment is Nia, right? But this is the magnetic potential energy of a magnetic dipole, right? I hope this is clear. Now next point is the Savart law. Now this is the very important law in this chapter. Now this law gives the relation in between the magnetic field produced by the current carrying wire and its current. Here we consider the current carrying wire and the current I is passing through this wire. Now what is the direction of magnetic field? We have seen that the direction of magnetic field is by using the right hand thumb rule. Here the direction of the magnetic field at this side is in outward direction, right? Here the magnetic field is in outward direction and perpendicular to this plane, and similarly the magnetic direction of the magnetic field at this side is perpendicular to the plane and in inward direction, right? But here at point P the direction of magnetic field is in inward direction, right? Now according to this Savart law, the magnetic field at point P due to the current flowing through this small element, right? Only the current flowing through this small element dl is denoted by suppose small quantity or the differential quantity dB, right? Here this dB is equal to what, right? According to Savart law, the dB is equal to here mu0 upon 4 pi I dl cross r divided by r cube, right? Now this is the formula for the Savart law. बघा आता हे रिलेशन काय इंडिकेट करते? Here the magnetic field is proportional to the current flowing through the small element dl, right? Now the magnetic field is also directly proportional to the length of the small element, right? And here the magnetic field is also inversely proportional to the distance of that point from the center of the small element dl, right? Now in magnitude here we get dB is equal to mu0 upon 4 pi I dl r sin theta divided by r cube. Here r get cancelled, we get the formula mu0 upon 4 pi I dl sin theta upon r cube, right? Sorry, r square. Now here what is the proportionality? Here dB is directly proportional to what? Current flowing through the wire. Similarly this dB is directly proportional to the length of the small element dl, and it is directly proportional to the sine of the angle between the line joining the point and the dl vector, right? ह्याच्यामध्ये असलेला जो अँगल आहे थीटा त्याला तो कसा आहे डायरेक्टली प्रोपोर्शनल, and here this dB is inversely proportional to the square of the distance between the point and the center of the small element dl, right? But this is the very simple Savart law. This is useful to find out the magnetic field around the current carrying conductor, right? Here what is the mu naught? Here mu naught is the permeability of a free space or the permeability of a vacuum. We remember the equation or the relation in between mu naught and epsilon naught. Here epsilon naught is the permittivity of a free space and mu naught it is the permeability of a free space. Here suppose c is the velocity of a light in air, then we get the relation c is equal to 1 upon under root of mu naught into epsilon naught, right? Remember this relation, c is equal to 1 upon square root of epsilon naught into mu naught. Now first application of Savart law. Here we find out the magnetic field due to the current in a straight wire. First here we consider the infinite long straight wire. But for this infinite long straight wire, here we consider the I is the current flowing through this wire, and this wire is a infinite wire. That means here we consider the minus infinity and here is the plus infinity, right? Wire is infinite. आता Savart law मध्ये आपण स्टडी केलं होतं, जर वायरचं स्मॉल इलेमेंट डी एल असेल आणि तो जर आर डिस्टन्सवरती असेल तर या पी पॉईंटला मॅग्नेटिक फील्ड किती असणार आहे? स्मॉल मॅग्नेटिक फील्ड डी व्ही इज इक्वल टू मी 0 अपॉन 4 पाय आय डी एल साइन थीटा अपॉन आर स्क्वेअर, राईट, अकॉर्डिंग टू Savart law. पण आपल्याला या ठिकाणी पूर्ण इन्फिनाइट वायरमुळे जे काय मॅग्नेटिक फील्ड जनरेट होईल पी पॉईंटला ते फाइंड करायचे. सपोज वी हियर डिसाइड बी इज दी टोटल मॅग्नेटिक फील्ड ॲट पॉईंट पी ड्यू टू दी इन्फिनाइट वायर, राईट. मग हियर due to the small element dl, the magnetic field is db. So how much is the total magnetic field at point p due to the infinite wire? Here we get b is equal to integration from minus infinity to plus infinity of this db. Okay, this is the total magnetic field at point p. Now here by using the geometry of figure, here r is what? R is the distance of that point from the center of the small element, and capital R is the perpendicular distance of that point from the straight conductor. So here we write r is equal to what? R is equal to under root of L square plus R square, and here L is the length of that small element from the point O. ठीक आहे, O पॉइंट पासून DL हा एलिमेंट जर मी L अंतरावरती कन्सिडर केला तर R चा फॉर्म्युला काय तयार होतोय? अंडर रूट ऑफ L स्क्वेअर प्लस R स्क्वेअर. ठीक आहे, मग हियर वी गेट R स्क्वेअर इज इक्वल टू L स्क्वेअर प्लस R स्क्वेअर, राइट. Similarly, what is sin theta here? Here theta is the angle between the direction of small element and line joining the point. Here this angle is theta, therefore this angle is pi minus theta, and here we know that pi minus theta is equal to sin theta, and here we get sin theta is equal to R upon small r, that means capital R upon small r. Now by using all this mathematics and we solve this formula, we get b is equal to mu 0 I upon 2 pi r, right. But this is the magnetic field at point P due to the infinite long straight conductor, right. Simple formula. What is r here? R is the perpendicular distance of that point from the straight conductor. I is the current flowing through that conductor, and mu naught, it is the permeability of a vacuum, right. Now next point, next is the suppose conductor is semi infinite straight wire. कंडक्टर आता कसा कन्सिडर केलाय? सेमी इन्फिनाइट असेल. लास्ट पॉइंटला पण तो इन्फिनाइट मानला होता. आता हा जर सेमी इन्फिनाइट जर असेल तर या कंडिशनमध्ये हा जो एंड असेल तो आपण एक त्याचा वन एंड मानला. मग वन एंड पासून इथपर्यंत वायर कशी असेल तर इन्फिनाइट असेल, म्हणून याला म्हटले सेमी इन्फिनाइट वायर. नाउ हियर वी फाइंड आउट द मॅग्नेटिक फील्ड ॲट पॉइंट पी विच इज ॲट अ डिस्टन्स परपेंडिकुलर डिस्टन्स आर फ्रॉम द वन एंड ऑफ द वायर. ठीक आहे, आता जर ही वायर इन्फिनाइट असेल तर इन्फिनाइट वायर होती त्यावेळेस आपण मॅग्नेटिक फील्ड किती घेतलं होतं? फॉर इन्फिनाइट स्ट्रेट वायर, for infinite straight wire, magnetic field is what? B is equal to mu 0 I upon 2 pi r, right. This is for the infinite straight wire, and here we get the semi infinite straight wire. आता ही वायर कशी असणार आहे? सेमी इन्फिनाइट असणार आहे, म्हणजे जी इन्फिनाइट वायर होती त्याची ही कशी असेल? हाफ असेल, राइट. मग हियर वी गेट द मॅग्नेटिक फील्ड ॲट पॉइंट पी इज हाफ दॅट ऑफ द magnetic field due to the infinite straight wire. But here we get the for semi infinite straight wire, the magnetic field is B is equal to mu 0 I upon 4 pi r. ठीक है, this is the magnetic field due to the semi infinite straight wire. ठीक है, म्हणजे दोन्हीमध्ये फरक काय आहे? फक्त फायनाइट वायर जर असेल तर mu 0 I upon 2 pi r, आणि जर सेमी इन्फिनाइट असेल म्हणजे हाफ वायर जर असेल तर त्याचं मॅग्नेटिक फील्ड पण काय करायचं आहे? हाफ घ्यायचं. हियर वी गेट बी इज इक्वल टू मी 0 I अपॉन 4 पाय आर. नाउ नेक्स्ट इम्पॉर्टंट इज दी सपोज वायर इज फायनाइट. Suppose L is the length of this wire, this is the finite length of this wire, and current I is flowing through this wire. Now here we find out the magnetic field at point P. Here P point is at a perpendicular distance capital R. ठीक आहे, P point कुठं असेल तर R या perpendicular distance वरती असेल, and this conductor is a finite conductor. We here imagine the capital L is the length of this wire. Now here we join the two end of this wire up to the point P. Right, suppose A and B, these are the two ends of this wire. Now the angle generated at this point P, suppose this angle is theta 1 and this angle is theta 2, right. These two angles are with the perpendicular distance and the line joining the ends of this wire. ठीक आहे, what is theta 1 and theta 2? theta 1 आणि theta 2 हे जे दोन अँगल कन्सिडर केले P पॉइंटला तयार झालेले अँगल असतील ह्या परपेंडिक्युलर मुळे, हा परपेंडिक्युलर डिस्टन्स आहे इथं R डिस्टन्स. मग आता या कंडिशनमध्ये तो फॉर्म्युला काय येतोय बघा, आपण लास्ट पॉईंटला पाहिलं होतं सेमी इन्फिनाइट वायरला मॅग्नेटिक फील्ड किती होतं त्याचं, मॅग्नेटिक फील्ड ॲट पॉईंट P ड्यू टू दिस सेमी इन्फिनाइट स्ट्रेट वायर B इज इक्वल टू μ0 I अपॉन 4 pi R. ठीक आहे, दिस इज द मॅग्नेटिक फील्ड ड्यू टू द सेमी इन्फिनाइट वायर, राइट. दिस इज फॉर सेमी इन्फिनाइट वायर. सेमी इन्फिनाइट वायर जर असेल तर मॅग्नेटिक फील्ड आपण या पद्धतीने घेतो, पण आता ही वायर जी आहे ती सेमी इन्फिनाइट नसून एक फायनाइट वायर आहे, तिची लेंथ आपण L इमॅजिन केलेली आहे, म्हणजे ए बी ही वायर असेल. तर मग अशा कंडिशनमध्ये या फॅक्टरमध्ये काय चेंज होतो बघा, ह्या फॅक्टरमध्ये हिअर वी कन्सिडर I इज द करंट, R इज द परपेंडिक्युलर डिस्टन्स, राइट. परमेबिलिटी इज μ0. हिअर द मॅग्नेटिक फील्ड ॲट पॉईंट P इज B इज इक्वल टू μ0 I अपॉन 4 pi R इंटू साइन थीटा 1 प्लस साइन थीटा 2. ठीक आहे, हा फॅक्टर फक्त याला लक्षात ठेवायचं आहे, साइन थीटा 1 प्लस साइन थीटा 2. थीटा 1 आणि थीटा 2 कसा घ्यायचा तो लक्षात घ्या. नाउ नेक्स्ट पॉइंट इज द फोर्स ऑफ अट्रॅक्शन बिटवीन टू इन्फिनाइट लॉन्ग पॅरलल वायर्स. नाउ हियर वी कन्सिडर दिस 1 and 2 are the two infinite long parallel wires, right. Here first conductor and this is the second conductor, these are the infinite long parallel wires, and here I1 and I2 are the current flowing through this wire. Now according to Savart law, the magnetic field produced by this first conductor is suppose dB. Now next point is the force of attraction between two infinite long parallel wires. Here we find out the force of attraction between these two conductors, conductor 1 and conductor 2. These conductors are infinite long conductors, right. Now we have seen that the magnetic field due to the infinite long straight wire is B is equal to μ0 I upon 2 pi R. What is R here? R is the distance of that point from the straight conductor. Here we consider the distance between these two conductors is D. Now what is the B here? Suppose the current flowing through the second conductor is I2, then magnetic field produced by this conductor is suppose B2. Now this B2 is at a perpendicular distance D is μ0 I2 divided by 2 pi D. ठीक आहे, हा फॉर्म्युला समजला. आपण स्ट्रेट कंडक्टर इन्फिनाइट लॉन्ग स्ट्रेट कंडक्टरसाठी हा फॉर्म्युला घेतला होता, B इज इक्वल टू μ0 I अपॉन 2 pi R. मग आता इथे R च्या ऐवजी मी D घेतलाय, कारण ह्या स्ट्रेट कंडक्टरपासून D ह्या डिस्टन्सवरती मला मॅग्नेटिक फील्ड कन्सिडर करायचे. ठीक आहे, द मॅग्नेटिक फील्ड प्रोड्यूस्ड बाय द सेकंड कंडक्टर इज सपोज B2 and at points here the magnetic field becomes μ0 I2 upon 2 pi D. Now what is the direction of this magnetic field at point here? I know that according to right hand thumb rule the magnetic field is in outward direction for the first conductor, right. Here we get the magnetic field is in outward direction and perpendicular to the conductor. Now similarly suppose magnetic field generated by the first conductor due to the current I1 is suppose B1. Now here we get the magnetic field B1 due to the first conductor, right. Now what is the direction of this magnetic field B1? Now according to right hand thumb rule, here the magnetic field is in a inward direction. हे magnetic field कसं असणार आहे, inward direction असणार. आता त्याची magnitude काय असणार आहे, this is the magnetic field due to the current flowing through the first conductor, right. मग this is at a also perpendicular distance d, मग therefore we get mu0 I1 upon 2 pi d. This is the magnetic field B1. आता शॉर्ट मध्ये काय लक्षात घ्यायचं बघा, याच्यामध्ये सेकंड कंडक्टर जो आहे तो B1 या मॅग्नेटिक फील्ड मध्ये ठेवलेला असेल आणि फर्स्ट कंडक्टर जो आहे तो B2 या मॅग्नेटिक फील्ड मध्ये ठेवलेला असेल. नाउ व्हाट इज द मॅग्नेटिक फोर्स हियर? नाउ हियर वी कन्सिडर द फोर्स acting on the conductor 1 is suppose F1. Now how much is this force F1? We know that the magnetic force F is equal to ILB sin theta. Here theta is the angle between the direction of the conductor and direction of magnetic field. Here that angle is 90 degree. Therefore the force F1 on a first conductor becomes I1, length is suppose L and magnetic field is B2. So the force become F1 is equal to IL B2. How much is the B2? B2 is equal to mu0 I2 upon 2 pi d. Therefore formula becomes I1 L mu0 I2 upon 2 pi d. That means in simple we say that F1 is equal to mu0 upon 2 pi d, and here we get I1 I2 and length L, right. But this is the formula for the force acting on the first conductor. F1 is equal to mu0 I1 I2 L upon 2 pi d. Now how much is the force acting on the second conductor? Here we consider the force acting on the second conductor is F2, and which is equal to what? Current I2, length is same suppose L, and the magnetic field is B1. So here we get current I2, length L, magnetic field is mu0 I1 upon 2 pi d. So in simple the F2 becomes F2 is equal to mu0 I1 I2 L divided by 2 pi d. For here we see that the F1 and F2 are same. This is the force acting on the conductor I1 and conductor 1 and 2. So by using these two equation F1 and F2, we find out here the force per unit length acting on these two conductor. Here we get force per unit length is equal to what? Here we get L divide to this force, then formula becomes F upon L is equal to mu0 I1 I2 divided by 2 pi d, and here d is the perpendicular distance between two straight conductor, and I1 and I2 is the current passing through that conductor respectively, right. But this is the formula for the force of attraction between the two infinite long parallel wires kept at a distance small d, right. This is the very simple formula. Now next point,